Welcome to Python Programming Beginner to Intermediate. This complete hands-on guide will take you from the basics to more advanced concepts in Python. Welcome to our session on getting started with Python programming. We'll explore the essentials to kickstart your journey from beginner to intermediate levels. Python is a high-level, interpreted language known for its readability and productivity. Its clean syntax reduces code complexity, making it easier to maintain. Python is versatile, used in web development, data analysis, automation, machine learning, and more. Major organizations like Google, NASA, and Instagram rely on it. While not the fastest at runtime, it's quick to learn and highly productive. You write Python code in .py files using any text editor or integrated development environment. The Python interpreter executes your code line by line, eliminating the need for a separate compile step. Use Python 3, as Python 2 is obsolete. Utilize the read eval print loop for instant experimentation by typing Python in your terminal. The print function displays text on the screen. Strings are text in quotes. Comments start with hashtag and are ignored by Python. Python uses new lines, not semicolons, to end statements. Indentation is crucial for structure. Example: print hello world. Outputs text. Use separator and end parameters to customize output, like print A, B, separator. Welcome to Section 2, Variables and Data Types. We'll explore how Python handles data storage and manipulation. In Python, use is equals to for assignment, like name is equals to Alice. No need to declare types. Python infers them. Follow naming rules. Start with a letter or underscore and use snake underscore case. Assign multiple variables in one line. X, Y, Z is equals to 1, 2, 3. Swap values easily. X, Y is equals to Y, X. Understand key data types in Python. Integer for whole numbers, float for decimals, string for text, boolean for true or false, and none type for no value. Use type to check a variable's type and ice instance to verify it. Welcome to the section on strings. We'll explore how to work with text data effectively. Strings are indexed with S0 for the first character and S-1 for the last. Use slicing like S1 to 4 for substrings. Strings are immutable, reassign to change them. Concatenate with plus or repeat with asterisk. The length is found using len value of S. Explore useful string methods in Python. Use upper, lower, title, and capitalize for case conversion. Search with find, count, starts with, and ends with. Clean strings using strip, lstrip, and rstrip. Split strings into lists with split and join them back with join. Replace text using replace old, new. Strings offer a modern, efficient way to format strings in Python. By prefixing with f and embedding expressions in brace, you can include variables, perform calculations, and format numbers. For instance, use 2f for 2 decimal places or greater than 10 for padding. Introduced in Python 3.6, f-strings are faster and cleaner than older methods. Welcome to Section 4, Numbers and Math. We'll explore basic operations, integer division, modulo, and powers, along with the math module for advanced calculations. Explore basic math operations: addition, subtraction, multiplication, and division. Use floor division for whole numbers and modulo for remainders. Exponents are calculated with 2 asterisks. The math module offers functions like square root, ceiling, and floor. Examples include 10 plus 3 equals 13 and math.sqrt 144 equals 12.0. Welcome to Section 5, User Input and Casting. We'll explore how to handle user input and convert data types effectively. The input function always returns a string, even for numbers. Use integer function to convert strings to integers and float function for decimals. String function converts numbers to strings. Remember, 0, single quotes, none, and square braces are falsy. For safe conversion, use try except to handle value error when converting input to integers. Welcome to Section 6, Making Decisions. We'll explore how to use conditional statements to control the flow of your programs. In decision making with if elif else, if executes a block when its condition is true. Elif checks subsequent conditions, while else serves as a fallback. Proper indentation is crucial. You can nest if statements. For example, a score of 78 results in a grade C. Ternary operators offer concise conditionals like determining pass or fail. Comparison operators like equals to and not is equals to check equality and inequality. Logical operators such as or and not evaluate multiple conditions. For example, x is equal to 15 satisfies x greater than 10 and x less than 20. Chained comparisons like 10 less than x less than 20 are Pythonic. Use in to check membership in lists. Example Arctos, apple in fruits. Welcome to section 7, where we explore loops. This section will delve into how loops function in programming, allowing for efficient iteration over sequences. The for loop iterates over sequences, use range for numeric sequences, and enumerate for index and value. Break exits the loop while continue skips to the next iteration. Example, iterating over a list of colors or using range to print numbers. The while loop continues as long as its condition is true. Use while true for infinite loops, but remember to include a break to exit. Increment counters each iteration. For input validation, loop until valid input is received. The else clause executes if the loop ends without a break. Welcome to our discussion on lists. We'll explore how to create, access, and manipulate ordered collections in programming. Lists are ordered. Collections created with square brackets like number is equal to 1, 2, 3. They are mutable, allowing changes, additions, or removals. Lists can contain mixed types, including other lists, as seen in nested lists like matrix is equal to a 2 by 2 list 1, 2, 3, 4. Access elements using indices, with negative indices accessing from the end. Explore list methods. Append adds to the end, insert places at a specific index, and remove deletes the first occurrence. Use pop to remove and return an item. Sort lists in place or create a sorted copy. Count occurrences, find positions, and calculate sums. Copy lists with copy or slicing. Welcome to section 9, where we explore tuples and sets. We'll delve into their characteristics and uses in programming. Tuples are immutable sequences created using parentheses, like point is equals to 10, 20. They are ideal for data that shouldn't change, such as coordinates or RGB red, green, blue values. Unpacking allows assigning elements to variables. Example xy is equal to point. For single items, include a trailing comma. Single is equals to 42. Tuples can also be used as dictionary keys. Sets are collections of unique, unordered items. They automatically remove duplicates and offer fast membership testing. Key operations include union, intersection, difference, and symmetric difference. Use sets to efficiently remove duplicates from lists or test membership. For example, creating a set from a list removes duplicates instantly. Welcome to our discussion on dictionaries. We'll explore how they store key-value pairs, ensuring unique and immutable keys, and maintaining order in Python 3.7 and above. Dictionaries store data as key-value pairs using curly braces. Keys must be unique and immutable, while values can be any type. Access values with brackets or the get method. Python 3.7 Plus maintains insertion order. You can add, update, or delete entries and check for key existence efficiently. Explore dictionary methods like keys, values, and items for efficient data handling. Use update to merge dictionaries. Dictionary comprehension allows concise creation where KA maps to V for each key-value pair in items. Loop through keys, values, or key-value pairs for flexible operations. For example, squares is a dictionary where each number n maps to n squared for every n in nums. Welcome to our discussion on functions. We'll explore how to define and call functions, including parameters, return values, and default parameters. The def keyword initiates a function definition. Parameters are variables in parentheses that receive values. The return statement sends a value back to the caller. Default parameters make arguments optional. A docstring documents the function's purpose. Functions can return multiple values as a tuple, like in munmax avg, which returns minimum, maximum, and average. Explore *args for collecting positional arguments into a tuple, and *kwargs for collecting keyword arguments into a dictionary. Use lambda for concise anonymous functions. Higher order functions like map and filter apply, or filter functions over collections. For example, a function like add all sums numbers, profile prints user information, and a lambda function can be used to double values. Welcome to our discussion on scope and modules. We'll explore how Python manages variable visibility and the role of modules in organizing code. In Python, variable scope is crucial. Local variables exist only within functions, while global variables are accessible throughout the file. Use the global keyword to modify global variables inside functions, but it's best to avoid this practice. Follow the LEGB rule: local, enclosing, global, built-in for name resolution. Learn to import modules into Python using import and from import. Use import math for full modules or from math. Import square root for specific functions. Rename with import numpy as np. Python's standard library offers 200 plus modules. Install third-party packages with pip install. Examples include math, random, datetime, and OS. Welcome to our discussion on file handling. We'll explore how to efficiently manage files in Python, covering essential operations like reading, writing, and appending data. To handle files in Python, use the open function with modes like R, W, A, and B. Always use a with statement to ensure files close automatically. Use read to get the entire file as a string, read lines for a list of lines, and a for loop to iterate line by line. Welcome to our discussion on error handling. We'll explore techniques to manage errors effectively in your code, ensuring robust and reliable applications. In error handling, use a try block to wrap risky code. Catch specific errors like value error or file not found error with except. The else block runs if no exceptions occur, while finally always executes for cleanup. For example, handle input errors or missing files gracefully to ensure robust code execution. Welcome to the section on OOP basics. We'll explore the foundational concepts of object-oriented programming. Classes are blueprints defining attributes and methods. Objects are instances of these classes. The init method is a constructor, initializing object attributes. Self refers to the current object. In the dog class, species is a class attribute, while name, breed, and age are instance attributes. Methods like bark and info define behavior. Instance methods operate on specific objects like deposit and withdraw in bank account. The dunderstr method defines the string representation for print, while dunderrepar is for developers. Class method uses CLS, and static method is a helper function. In our example, Alice's account balance updates with deposits and withdrawals, showcasing these concepts. Welcome to the intermediate OOP section. Let's delve into more advanced object-oriented programming concepts. Inheritance allows a child class to inherit attributes and methods from a parent class, reducing code duplication. Use super to call the parent's initializer. Override methods to change behavior in the child class. Eyes instance checks if an object belongs to a class or its parent. This enhances code reusability and flexibility. Properties and encapsulation in Python involve using private attributes, prefixed with double underscores, to hide data. The property decorator creates a getter, while xsetter allows validation logic. This encapsulation prevents invalid data assignments, as shown in the temperature class example, ensuring data integrity by controlling access and modification. Welcome to our discussion on list comprehensions. We'll explore how to create concise and efficient lists using Python's list comprehension syntax. List, dictionary, and set comprehensions offer concise syntax for creating collections. List comprehensions use dictionary. Comprehensions use key value for item in iterable if condition. Set comprehensions use expression for item in iterable. They are more Pythonic and faster than loops. Generators use parentheses for memory efficiency. Thank you for your attention. We encourage you to apply these concepts in your projects and continue exploring advanced Python techniques. Your journey in mastering Python is just beginning.